The problem, from my perspective, with this approach, and this is the approach used by Medicare, is that it creates a payment, what I call a payment cliff. And that's illustrated in the slide on the screen right now, where if you're an organization of a certain size, and imagine that your savings rate, and let's say your minimum savings rate is 3.5%, right? Well, if I'm at 3.1%, 3.2%, 3.3%, I get nothing. If I'm at 3.6%, 3.7%, now I'm eligible for shared savings. And in fact, at that point, Medicare would give me shared savings back to the first dollar of savings. But what if I'm at 3.49% or 3.499% or whatever the cutoff is? Like to have such a large difference in my payment due to what would actually be a very small difference in performance creates, in my mind, the opportunity for a lot of dispute and contention, because the provider is going to want to appeal their cost calculation and try to find that other half a percent of savings. Likewise, in other programs I've seen where they use tiers of savings, you get similar issues. So there are multiple cliffs in that setting where the provider, when they jump up from one tier to the next, their shared savings payment goes up. But again, at each of those cut points for those tiers, you create the opportunity for argument, because people are going to care very substantially about what might be very small differences. So an alternative to that kind of an approach is a sliding scale rewards methodology. And here I want to acknowledge work that I did with Michael Bailett at Bailett Health Purchasing, where we developed a sliding scale methodology for the Massachusetts Medicaid PCMH program. And this is a methodology where you still have you still adjust the shared savings payment based on the amount of savings that the provider organization generates, but you basically set up the shared savings methodology to reflect the increasing confidence you have that each marginal dollar of savings is real, right? So, when we start from the benchmark, the first dollar of savings very easily could have been caused by random variation. The second dollar of savings still could have easily been caused by random variation, but if that's slightly less likely than that first dollar, and so on. So as the savings rate increases, we're more confident that each dollar is not due to random variation, but in fact is real. The downside to this methodology is that it is more complex mathematically, and therefore more difficult to explain and administer. The math is not especially complicated, but it's more complicated than the minimum savings rate approach. But what you'd have in a sliding scale methodology is, as the savings rate increases, the shared savings payment percentage would increase as a continuous function, as opposed to jumping up in that step function that we saw and we see illustrated here. And you could build the sliding scale to be a linear relationship, or if you had evidence to support a nonlinear relationship, you could also build it as a curve. So we think that the sliding scale methodology, even though it is a little more difficult or complex to explain, has advantages over the minimum savings rate methodology. Another approach that we can use to adjust for random variation is to compress the attributed savings for providers with small populations. As we've described now a few times, we're less confident about savings when they occur in small populations. So we can actually apply a methodology to compress those attributed savings to reflect that diminished confidence. And I'll illustrate that over the next couple slides. But the advantage of using this methodology is that you allow smaller providers to participate as independent organizations, right? You don't have to aggregate them. You don't have to exclude them. You could take them as they are and merely compress the savings that they for which they receive attribution. The downside is that for those smaller practices, the size of the incentives that are available to them And the size of the penalties in a two-tailed model would be compressed. So you might not have as great an impact on provider behavior, but you would be insulated from the impact of random variation. So let me illustrate what I mean. And I should mention that this compression of savings for small populations is something that we developed here at Discern for one of our health plan clients that was implementing a risk-based payment model for primary care. And the idea is that you would, if you look at this axis, you have an attributed patient population. In this graph, that population ranges from 0 to 10,000. And then for each of these population levels, you have a related compression factor. Essentially, what you do is you multiply any observed savings times that compression factor, and then base any shared savings payment on that compressed number. So you can see that this is a nonlinear relationship, and I'll explain that in a moment. But that for for 2,000 patients, the compression factor would be around slightly over 0.3. For 5,000, it's right around 0.75. So you're basically limiting the impact of the shared savings calculations in proportion to how uncertain you are about the savings result. And the reason that that's important is because, as we've already described now, and here's another illustration of this, small numbers drive variation. These results, what you see on the graph here, are actually results from the state of Maryland for its PCMH program, where when we did the shared savings calculations, we saw, and again, not really surprisingly, we saw that as the attributed patient size went down, and that's going from right to left on the x-axis, the variation in the results increased rapidly. And we still have a number of practices that are clustered around the benchmark, right? But then you see, especially at the very small provider population levels, you see a lot more volatility around a lot more variation around the amount of savings that we observed. And all of this data is very consistent with a lot of that variation being driven by random volatility. So by applying a compression factor to these calculations, you can basically offset that volatility. So here's a few examples of how this might work. If you had a provider organization that was generating $400 in per capita savings per year, if that provider group only had 2,000 attributed members, we would then compress that $400 down by the compression factor to $130. Right? They'd still get rewarded for the savings they achieved. It would just be reduced. At 5,000 population, where the compression factor is 0.75, they would get credited with $300 of those savings. And then at 10,000 or above, where the compression factor goes to 1, they get full credit for the savings they generate. So this is a way we can compensate for the size of the population without telling the smaller practices that they're not even allowed to participate in the program. And then the final, and thanks for bearing with me as I went through this list, the final methodology for adjusting payment rules is merely to assign or apply a savings cap to the savings amount that the practice or the provider organization achieves. And this is a way of making sure that we don't significantly overpay rewards due to random savings. But the argument against that is that it could limit providers' ability to earn rewards for the real savings that they generate. Right? So if a provider organization, in fact, has generated 20% in real savings, but you've got a 10% cap, well, that provider organization is not getting paid for a good portion of the savings that they generated. But this is a common component of shared savings programs. It is one of the components of the Medicare shared savings program, and was actually implemented here in Maryland based on some of the observations about the volatility of the results of the program. So briefly, before we start taking questions, in terms of evaluating all of these different methods, there are a number of different criteria that you should be asking yourself, looking at when you examine a shared savings program and the methodologies that it uses to control for random variation. Does the methodology adequately limit population level and patient level variation? But, and this in the parenthetical here, is not too much, right? And throughout these program implementations, the key is to strike the right balance, right? If you constrain population variation or patient level variation too much, you're going to exclude a lot of real improvements or a lot of real opportunities to drive savings. However, if you don't do anything, you're going to expose yourself to a lot of random variation. Is the framework, is the shared savings program fair to providers? Would be clearly an evaluation criterion. You want to reward them for real improvements. And that's where the idea of performance measurement, collecting that data, basing the payment on performance, I think is very important. Is the program fair to payers? Right? Again, we don't want to have a situation where payers are paying out rewards for non-existent improvements. So we have to have some methodology of insulating payers from paying for random savings. Is the program fair to patients? Is clearly a key issue. You know, ultimately, if these programs don't improve patient health, then they won't be around for long. And then, you know, more practical considerations: is the shared savings program very complex to administer? Does it take a lot of resources? Is it easy to explain and understand? These programs have to work in real-world settings, and so you have to balance some of the theoretical goals of these programs against just the real-world constraints of implementation. And so the bottom line is, what we really want to do is to isolate real savings, and we'll reward providers for that. And we basically can think of random variation as noise that masks the signal that we hope to isolate in terms of real savings. All of the techniques that I've described in the webinar thus far can help to address those goals. They all involve some trade-off of benefits and costs, both in terms of the implementation costs, but also the potential costs of excluding real savings. So what we need to do is adjust the sensitivity of these various mechanisms to retain as much real savings as possible and exclude as much random savings as possible. And I don't think yet anybody has figured out that formula, but there's a lot of experimentation, of course, going on around the country. These techniques that I've described today are not mutually exclusive. You do want to layer them in a way to address the different ways that random variation might pop up in the shared savings calculation. And ultimately, as I've described, we want to develop programs that strike that appropriate balance between constraining random variation, but still retaining what makes these programs work, which is leaving real incentives on the table for providers who do improve to earn additional revenue.